This is the Building Automation Monthly Podcast with Phil Zito, episode 89. Hey folks, Phil Zito here, and welcome to the Building Automation Monthly Podcast. And this podcast is dedicated to teaching you what you need to know to be effective in your building automation career. Each week we cover technical, sales, and operational topics that will really expand your mind around building automation systems and what building automation systems are capable of. Like I said, my name is Phil Zito. I've been in the industry for over 10 years. I've written a book on building automation systems called Building Automation Systems A to Z. And my mission is to help guide building and building automation professionals in learning more about building automation systems so that they can succeed in their careers. So in this episode, we are going to be diving into the topic of BAS and old buildings. Specifically, what do you do when you have an old building? Depending on what studies you believe, 40 to 60% of building automation systems installed are more than 20 years old. Now, on the surface, this wouldn't be much of an issue, but the real problem is that many of these building automation systems can no longer be replaced, meaning that you can't buy the parts, or the business that installed them or manufactured them has went out of business. And then, to make it even worse, the professionals who understand how to service these buildings, even if you had some spare stock of controllers and sensors and things like that, those professionals are leaving in droves. It's kind of fairly common knowledge in the building automation industry right now that we're in this kind of weird funk right now. Essentially, we have all these new folks who are entering, and they're in their 20s, they're in their 30s, they're entering the building automation space. And then you have all these 50 and 60-year-olds who are leaving the building automation space. And so you've got this gap in the building automation space of talent and of expertise and experience. And that is seen in a lot of places, but it's seen most when you start to look at what are called legacy systems, existing systems, systems that are no longer marketed, manufactured, or sold. It used to be that you would run a building automation systems 20, 30 years, and you would have someone who worked at your building or was part of your service provider and serviced your building, and that person knew your systems. But those people are leaving, and now the rate at which building automation systems are changing has accelerated greatly. So with that being said, with that problem of these older building automation systems that can't be replaced with existing parts, and you've got professionals who are leaving, so you don't have the expertise to work on these systems anymore, we're going to pivot to a 4-step strategy on how we address this exact problem. So the 4 steps are that you're going to benchmark your buildings, you're going to inventory your buildings, prioritize your buildings and systems, and then build a burden of proof to change your systems. I mean, it sounds pretty simple, right? But yet every day there are building professionals on the facility side, on the manufacturer side, on the system integrator side, who just are not able to get anywhere when it comes to executing a retrofit or replacing a BAS system. It's gotten to the point where it's almost comical. It would be comical, at least, if it wasn't causing buildings to fail and causing people to be uncomfortable and causing potential life safety issues. But what's going on here is that it's literally, until the building automation system totally crashes, no one wants to do anything. I remember I was working on this one hospital, and there was a pneumatic system, and we had tried for years to get them to replace this pneumatic system, but they were like, no, we don't need, it works perfect, pneumatics are better than DDC, you don't know what you're talking about, yada yada. I mean, you all have heard all this before. And it wasn't until a ball bearing off a fan got thrown through a coil, and that coil then started leaking water into an operating room, that they're like, oh, this could be really bad. This could be really, really bad. I mean, if someone had been in that operating room when this started to happen. And it was amazing how this hospital that had no money, they couldn't afford the retrofit, money magically appeared to go and retrofit these 3 air handlers to be DDC systems. It was just like the mystical unicorn fairy just rode into the room and dropped off a pile of money, and they're like, oh, look, oh, there it was all along. There's the money. Let's go take this money and actually invest in modernizing our BAS system. But that's what a lot of folks are facing, right? So that's why these 4 steps are so critically important. So even if you think you know where I'm going with these 4 steps, I encourage you to stay through the entire episode, because I think you're going to get a really new spin on how to approach this problem, something that you've probably not been exposed to before. So the first step, right, is to benchmark your buildings. In order to do anything, there's this saying that what gets measured gets done. I don't know who came up with that saying, but it is true. You know, when I tell my children I'm going to go and check their rooms look a lot cleaner than if I just trust that they're going to clean their rooms on a regular basis. Well, in order for you to understand what's going on with your buildings and actually act in any way, shape, or form on this problem, you need to have a snapshot of what the problem really is. Because quite often what will happen is we'll wait for a system to fail, or we'll wait for someone to start screaming that a space is uncomfortable. And both of those are really poor strategies for servicing and retrofitting. A better strategy is to go and gather your O&M so that you have your square footage of your building, and gather your past 12 months of utility bills. Then you take that information and you're going to go to, at least in the United States, what's called Energy Star Portfolio Manager. And I would imagine this would work for people outside the United States. You would just have to go and match up the climate, the region, to your climate. So, for example, Ireland would match up to Seattle. And that's about the only example I have. I guess Houston would match up to, over there in Asia where it's really hot and humid. Louisiana, that kind of area. So what you want to do is you want to take this Energy Star Portfolio Manager, which is free, and go and put in your square footage of your shell, of your building core and shell. And then you want to put in your utility bills and the region you're in. And what that's going to do is that's going to benchmark your building and give you a score. And then you can compare to other buildings of the same vertical market, meaning if you're in healthcare, if you're in commercial real estate, etc. You can compare to those buildings how your building ranks. And you can immediately get a snapshot of if your building, is on par with high performing buildings, or if your building is really, really low. Because the reality is most folks, whether you're a service provider, an owner, integrator, you just don't have a ton of time to adequately survey more than one building without getting paid for it. I mean, let's be real. I mean, if folks are going to pay you to do surveys, that's fine. But to do 40 buildings for free and not be guaranteed to get anything out of it, or if you're actually operating the building and you have to take your field staff and take them off service calls and off maintenance and have them survey buildings, if they even know how to do that, that's just a huge cost. So an initial kind of first glance is to go and just enter your data. And since it's free and it's really easy to enter, I think there's live training webinars on it at least every week, and they go in and they tell you exactly what to do. So you go in there, you enter the data, and then you have this ranking, and then you're able to actually see, okay, this building is at a 30, and so it's a scale of 0 to 100, and this building's a 30, and every other building in my region's like a 70. That tells me that this building probably has issues. And so I probably want to focus my initial look at my really low performing buildings. Because here's the deal. What I want you to be thinking about through this entire process, and we have a temptation as HVAC and BAS and controls and those kind of backgrounded people, we want to solve the problem with technology. And I get that. There's a there's a time and a place to do that. But in order to solve this problem, we first have to solve it with finance. Because at the end of the day, if we can't get a capital infusion, if we can't get folks to give us money, then we're not going to be able to go and retrofit anything. So the name of the game here is to find out how much financially this non-performance is impacting us, right? And for some of you, there's going to be a really cool side benefit, because this is probably going to be the first time some of you have ever dove into your O&M manuals, because those things kind of sit on a shelf and collect dust until there's actually a problem. So it'll be cool because you'll get to go through that and make sure those are up to date. Which then brings us to step 2 of inventorying your buildings. So you've ranked your buildings. You've figured out which ones you're going to look at first. Now you're going to do 2 types of inventory, right? You're going to do a physical inventory and a technical inventory. So for a physical inventory, the first thing you got to make sure is that you have your O&Ms. Those are your operating manuals. Those are essentially when building is built, you have design submittals, and those design submittals get used to implement the controls. That's how you install the controls, you install the systems. Then after the project's complete, you do what are called red lines, where you edit those diagrams, those submittals, to be accurate. And then you package all that up along with product cut sheets and other things to create a O&M manual, an owner's manual, essentially, operations and maintenance. And that manual is going to be your most important asset initially, because it's going to help you identify the systems, how they're sequenced, how they're programmed, what devices they have, because that's what you want to do. You want to find your low-performing buildings. You want to understand what kind of systems they have, what kind of devices they have. And then this is where you get your hands dirty. You go and you make sure that these systems are actually operating. I remember going to a large county building, and they literally had a 4-foot by 4-foot hole in the side of the building where there used to be an outdoor air intake. And it was just a hole. And I was dumbfounded that I'm staring out from the 6th floor out this 4-foot by 4-foot hole. And I'm like thinking to myself, like, how could someone not notice this? And it became really apparent why very quickly. No one had ever done maintenance on the system. You saw stuff was in hand, and that means it's in manual, essentially. Stuff was detached. Sensors were dangling off the unit. And this is where you're going to really just, is it even operational? Because, I mean, that's such a quick fix, right? That's something that doesn't require a ton of capital. If you've got a damper actuator that for whatever reason got taken off the unit a long time ago just because someone didn't want to deal with it, or they're doing maintenance and they took it off and forgot to put it on, that is such a quick fix. And you'll find in my experience 5 to 10% of quick fixes that you, with very minimal effort, you can go make these changes. Now here's the deal though. You have to have measured the building performance prior to doing anything. Because at the end of the day, what's our goal here? It's to make a financial case. And in order to make a financial case, we want to document the changes we make and show their impact on the financial performance of the building. So the cost of utility, the cost of maintenance. Because if we can go and show a good enough story, we'll be able to get capital funds for us to go and invest on upgrading our system in the future. Another thing you want to check for is backups. You want to make sure, especially with older systems, that you have backups of programs, that you have backups of graphics, that you have just backups of anything that you would need in order to be able to replace, retrofit, or service that building. And you'd be shocked how many buildings I go to where the folks do not have backups. They simply don't have anything if that system were to fail. Now, I mentioned there are 2 types of inventories, right? There's physical and there's technical inventory. Now, technical inventory, here's the deal. This is more of looking at your talent that is in the building. And you have to ask yourself these 3 questions. And you got to be really honest with yourself. Can you support the systems? Meaning, do you have folks on staff who have both the bandwidth and the technical ability to support your legacy systems? How much talent capacity do you have? Meaning, of these folks who actually can execute, do they have the bandwidth? Do they have the time to go and actually work on these systems? And then how much time do you have left with that talent? This is something a lot of folks don't think about, and it's kind of scary. Say you have Joe, and Joe's 55 years old. He understands the system like no one else. But Joe has always dreamed of driving around an RV with his wife and traveling the U.S. because as a kid, his parents they worked until they died, and he doesn't want that. So he's thinking, hey, I'm 55, I'm leaving, I'm getting in my RV. If you haven't had this conversation with your team to understand their plans, to understand, how long are they going to be there, and to have a plan to at least have someone to work alongside them to pass that tacit knowledge. That's knowledge that's inside someone's head that's not shared. So to pass that knowledge to other folks, if you don't have a plan to do that, then you're really shooting yourself in the foot. And once again, that's something that it's just the matter of making it happen, of going and setting up time where you say, okay, well, when you do this system, we're going to pick 4 or 5 tasks, and we're going to have someone shadow you, and you're going to teach them those tasks. And within 6 months, they're going to implement the tasks. And usually what you can do is you can have the very simple tasks done by the person who's getting trained, and then have the more complex tasks done by the person who has that experience. Now, this brings us to step 3. So now you have a really good idea of what buildings are performing, and you have a good idea of the physical and technical capabilities in each building. Now you need to prioritize your buildings and systems. And when I say prioritize, remember, we're all about creating that financial proof that we can make a change to a building, and then that change we can extrapolate. We can basically say, well, if I did this and it resulted in this, then if I did more of that, it would result in more of this. So, it's kind of like saying, well, if I ate 1 apple a day and it resulted in me getting healthier, then I could eat 10 apples and get even healthier. Yeah, maybe that's a bad analogy, but you get where I'm going with this. So the thing here is that you've got to prioritize your buildings and your systems. So first you need to decide on the criteria for priority. And usually here's how I see it broken out, right? I see that you're going to look at life safety. Want to make sure people stay alive. That's pretty important. Then you're going to look at core system functionality, meaning if there's like a central utility plant that cools all of the buildings on the campus, that's pretty important. That would be a big deal if that went down. So you want to look at that core system functionality. Then you look at business impact. Now, business impact is where this is going to either make it to where you can't teach in the classroom, you can't have a patient in the patient room, your tenants are getting pissed off and they're like, hey, I'm leaving because the air doesn't work in here. And so that is business impact. And then occupant comfort. Because in some cases, and this is why I list occupant comfort last, in some cases, the business impact and occupant comfort are going to be the exact same thing, like commercial real estate. If someone goes into an office building and it's 95 degrees, they're not going to want to lease that if that's every single day. Well, occupant comfort, though, to other vertical markets, maybe you're talking about a prison, maybe you're talking about a data center, things like that, where occupant comfort isn't the number one priority. However, it is important. Usually, though, by the time you've went through criteria 1, 2, and 3, you'll have narrowed down your list so much that you'll know exactly what buildings you're going to do. And then you just follow through. Once you figured out your buildings, then you follow up with your systems using the same criteria. Which that then brings us here to step 4. Now, this is the most important step. Now, granted, this step requires you to have done steps 1, 2, and 3, right? It requires you to have benchmarked your buildings, inventoried your buildings, and prioritized your buildings and systems. However, once you've done that, this is where a lot of folks just fall flat. They do all this, they get all this information, and they don't know what to do. So here's what you need to do. First thing you need to do is you need to look for sponsors or people who support your idea. They realize that going and retrofitting the building and making it more comfortable, making it more life safety oriented, making it more adhering to whatever the business goal of the building is a good idea. And so these people are usually, 1 to 2 levels above you as far as the career pecking ladder. And these folks are going to have awareness of what it makes the leadership, and when I say leadership, I'm talking about whoever's going to make the decision on you getting funding to do a retrofit. They're going to have awareness on what makes those folks tick, what those folks look for when they're evaluating projects. When they're saying, hey, I'm going to make a decision whether I'm going to invest my money in A, B, or C, these sponsors that you're looking for, these guides, they're going to understand what is important to those leaders. And then they're going to be able to tell you. They're going to be able to tell you a couple things that you're going to want to specifically ask for. The first is you're going to want to ask for key performance indicators. How do they measure success? Is it reduction in BTU per square foot? Is it reduction in cold calls? Do they simply look for internal rate of return, which is a financial measure? Do they look for cash flow measures and cash flow projections? How do they measure what they are looking for? And also, how do they measure return on investment? Because oftentimes that's something that we use and it's a term that's tossed around, but how you measure return on investment is going to differ from organization to organization. So then once you've done that, you've figured out the metrics that they're going to measure, you've identified the person who's going to understand this information, then you want to ask for past examples of successful and unsuccessful proposals, meaning that you want to go and find folks who have succeeded in getting their projects approved, and you want to get copies of those proposals. What was it that made that proposal successful? Was it a solid explanation of the return on investment? Were there some key words and phrases in there that resonated with leadership? You want to understand this. But then on the flip side, you want to get a copy of some unsuccessful proposals, things that were rejected, even though they seemed like they should have been approved. So that's the caveat with that. That's the important caveat with that, right? Is that you want to get unsuccessful proposals, but you don't want to get like, oh, well, we're going to install special parking for every, facility technician so that he can be at the front of the building. No, I mean, that's just silly, right? You want to have proposals that they made sense. Like, let's replace all our T8 lights with LEDs. It made sense. It had a good projection for savings, but yet for some reason it didn't get approved. And you want to really become a student of why the proposals get approved and why they don't get approved. Because once you understand that, then you're going to understand, what are they looking for, what is the leadership looking for that signifies success, meaning that if I see these 3 things in this proposal, it's a winning proposal to me, and I'm going to act on that. So you definitely want to go and understand that. And your sponsor, your guide, will be able to help you through that. And you also want to know examples of proposals that failed, so you can see, oh my goodness, I definitely shouldn't do that. I shouldn't write, you guys are stupid because you don't realize what we're going to save into a proposal. I've actually seen something kind of like that once, where they basically in the messaging it was, you're not really an expert. We're the experts. You don't know what you're doing. And you just need to be quiet and let us make the decisions. And I was like, oh, that's not going to go good for that person. and it did not go good for that person. So you want to understand the things that work, and then you want to copy what works. In the world we live in, for some reason, there's everyone's hey, we need to do something new and novel. Everything needs to be new and novel. But if you look at success, and you can see this, all over the place. And I think there was a good article written by the guy who owns Twitter or started Twitter. I think he's the one who wrote it. But he talked about success and how these, things start. And basically, folks just look at existing processes and they make minor tweaks. Like Uber looked at the taxi cab process and said, hey, this process doesn't work. I'm going to make a minor tweak. I'm going to combine technology to this process, and I'm going to make something that people want. Well, that's what you need to do. Just take what works and use what works. Don't try to reinvent the wheel. Don't be afraid to go to your peers in other buildings or in other campuses and ask them how they solved the same problem and copy what they did. Because if it worked for them, chances are very likely that it's going to work for you, especially if they're in the same vertical market as you are. Now, once you've done all this, you've put all this together, everything's well and good. Now you need to go and get funding for a small project. And here's kind of why I say you need to get funding. People value stuff that they spend money on. They don't value stuff that you give away for free. And I've learned this the hard way. As someone who creates online training programs for building automation professionals, I used to go and give stuff away for free because, I just wanted to help people. I was like, you know what? I get it. You live somewhere where you can't afford stuff, or, just for whatever reason, I just want to help you because you've been helpful to me. And I will say 99%, I could think of one, maybe two people, probably two people if I'm remembering correctly, out of the many that I've shared my programs with for free, who have actually went and used the programs. When you spend money on something, you have more value associated with it. You find that more important. So when these leaders go and they invest money into a small project, they're going to pay a lot more attention to the return. And if you show a return, so let's say, for example, you go and you find a building and you find that the air handler has no demand control ventilation strategy, meaning you're bringing in 100% outdoor air whenever that thing's on, even though you don't have to. And so you get a small project, you go and you do maybe option A or option B measurement and verification. So that's measurement and verification on a specific system. And you implement demand control ventilation, which means you reduce the outside air you can reduce it to 0 as long as the CO2 within the space is not above a certain threshold. So you install a CO2 monitor, you go and you make a change to your program so that you are then looking at CO2 and adjusting the outside air damper to control that CO2 value, and you start seeing savings. You then go and you report back with those savings, and you extrapolate those savings to maybe a couple other buildings. And then what happens now is you've proven savings in a specific scenario. So you find a couple more of those scenarios, and then you go and you replace those scenarios. Now, what do you need in order to go and implement demand control ventilation on an air handler usually? You usually need controls. So maybe you go and you start with a combination supervisory/field controller device that can have a field trunk hanging off of it for a limited number of controllers. And so you go and you put that supervisory/field controller in place that gives you access to essentially have a modern BAS in that building with graphics, with a user interface, with alarms, with trends, and with schedules. So now you can start to implement stuff. And as you go and you implement these changes, you implement these little projects, you now have a supervisory controller sitting in that building that you could potentially add 30, 40, 50 field controllers onto. And so now, after you go through and you do that for all your buildings, you do that to all your air handlers, you've introduced these supervisory devices, you've introduced potential trunks. Now you go for your next thing. You say, okay, I've went and saved energy. Now, what if I'm able to get better control of the spaces? Can I save energy there? And then you prove that out, and then you build off your field trunk that you just put in place, and you start adding field controllers on your VAV boxes. And you can see how if you strategize and think through these different scenarios, how you can then go and real quickly, it's going to be a little slow at first. It's kind of like a snowball rolling down a hill, right? It starts very small and gets bigger and bigger and bigger until it's so big that it's being carried by its own momentum and mass, and it just is plowing through any obstacles. And that's what you want to do here. You want to go and approach these problems, and then you want to do real quick wins that you can then justify to do immediate other wins, and then eventually you're going to get to the point where you've got such a burden of proof. You have this view in these leaders as you delivering results, as you being an expert, as you being reliable. You've made them look good financially, and now things are just going to get so much easier for you to go and get more funding, to be able to execute more projects, have more resources. And once you get that ball rolling, man, that is a good place to be. All right, so let's recap. So what we went over is this 4-step strategy to solve the problem of existing controls that you need to replace, but you don't have the funding to replace them. So we talked about in step 1, you want to benchmark your buildings. You want to go and gather data so that you know how each building performs. In step 2, you want to go and inventory your buildings. You want to have a physical inventory of the buildings, and you want to have a technical inventory of the buildings. Step 3, we talked about prioritizing your buildings and your systems and how you can do that. And then step 4, we talked about building a burden of proof to change your systems. So this was awesome. I love talking about this stuff. It's a little different than my more technical episodes, but I really look forward to your feedback on what you think about this episode. And here's what I want you to do. And my only request of you is that if you found this episode valuable, that you just go share it with other folks who you think would find it valuable as well. That would really help spread the word and spread the education of building automation throughout the industry. Now, some of you probably want to get a list of everything I've covered here. And for that, I say, that's awesome. If you go to buildingautomationmonthly.com/89, once again, that's buildingautomationmonthly.com/89, I have an opt-in form where you can go and sign up. And what you'll get in return is I will send you a checklist document that runs through these steps and tells you what you're supposed to do so that you can go and implement this in your own buildings. So definitely do that. And then you'll also get, when you sign up, you'll get access to several guides that I've put together. And these guides will really help you build on your building automation fundamentals, on understanding how to evaluate building automation systems and understanding how to optimize building automation systems. So you can sign up for that by going to buildingautomationmonthly.com/89 and just scrolling down to where you see the subscribe box, and it'll be very clear as to where that is. So thank you so much for listening. Thank you so much for working hard to grow in your building automation career. I'm so excited to be guiding you through this, and I will be talking to you all in the next episode. Thanks a ton. Take care.